Hello friends, how are you all? Welcome to Chemistry Art. Myself Bhai Kumar Patel. So friends, today we are going to discuss about the half-life period for the first order reaction. Okay. So what is half-life period? As we are knowing that the concentration when becomes half of the initial concentration is known as a half-life period. So here, see the definition I have written here. The time in which the concentration of a reactant is reduced to the half of its original concentration or original value is known as a half-life period. Okay, so suppose here we are doing one reaction. A is converting into the product. Okay, and here the initial concentration means T is equal to 0 time the concentration of A we are writing as a naught. Okay, and after some time the product is forming and the concentration of the product is, for example, half of the initial concentration of the reactant. It means that the concentration, whatever we have taken initial concentration, it is becoming half, and the time is known as a T half. Okay, so this is called half-life period, means the concentration when becomes a half of the initial concentration, means that half of the product is formed. That time is known as a half-life period. Okay, so now we have already discussed about the first order reaction for any time t, and we are here having the equation for the first order reaction. So let me write here the equation, and it is T is equals to 2.303 divided by K log a naught upon A, where what is A naught? A naught is the initial concentration and A is the concentration, final concentration at any T time. Okay, this is the first order reactions equation for any time, any T time. Okay, but what we have to take here, final concentration A is equals to A naught by 2. Okay, we have to write down the final concentration A is equals to A naught by 2. Okay, so at T is equals to T1 half, I can write this equation like this. I can write this equation for T1 half is equals to 2.303 divided by K log A naught. Initial concentration will be remain as A naught, and the final concentration, this A, okay, I have to write down A naught by 2. Okay, A naught by 2. So I can write this equation like this: 2.303 divided by K log A will be cancelled 2. Okay, and as we are knowing that the log value log 2 is equal to 0 0.3010. Okay, so 2.303 K log 2's value will be 0 0.3010, and we are getting the final value 0 0.693 divided by K. So this is our equation for the T1 half. Okay, so I can write T1 half is equals to, I can write T1 half is equal to 0 0.693 divided by K for the zero order reaction. Okay, now let's see the zero order reactions. We are having this equation, and now for the general expression for the half lifetime, let me write here general expression general expression for half lifetime, half life period. Okay, so now let's see general equation for the half life period, and for that here, see in a first order reaction, and we have already discussed about the zero order reaction. So let me write first here the equation for zero order reaction, half life period. Okay, half life period expression I can write as for the zero order reaction, zero order reaction. Okay, so zero order reaction, what is the equation for the zero order reaction? So it is the T1 half is equals to A naught by 2K. It means that T1 half is directly proportional to the A naught, initial concentration. Okay, So T1 half is directly proportional to the initial concentration. Okay, now let's see. We have already discussed this equation. Okay, for the first order reaction, for the first order reaction T1 half, we have derived this formula. It is 0.693 divided by K. So it means that here the T1 half is directly proportional with A naught? No. Here the power will be 0. It means that in the first order reaction, here in the first order reaction, T1 half is not depend T1 half is not depend on the initial concentration. So remember this thing. This is very important, that in a first order reaction, half lifetime is not depend on the initial concentration. It is independent of the initial concentration, and this is very important point. You should note down it. Okay, now for the second order reaction, let me write down T1 half for the second order reaction. So in second order reaction, T1 half will become directly proportional. T1 half is becoming the directly proportional to the A naught to the power minus 1. Okay, so here you can see the second order reaction half lifetime is directly proportional to A to the power minus 1. See here, for the zero order reaction, the T1 half is directly proportional with the initial concentration, but for the first order reaction, T1 half is not depend on the initial concentration because the power of A will be 0. See here, no any concentration is there. And now for the second order reaction, T1 half is inversely proportional, means A is in a denominator. Okay, so in general, we can write for the nth order reaction. Okay, let me write here for nth order reaction. For the nth order reaction T1 half, I can write for nth order reaction T1 half is directly proportional with A naught raised to 1 minus n. Whatever the number of reaction is there, you have to write down here. So n it is equal to 3, 4, 5, whatever the order of reaction. Or we can write this T1 half equation like this. So T1 half is directly proportional with A naught n minus 1. Okay, so this is for the nth order reaction, T1 half for the nth order reaction. And in last, let's see what will be the unit of the K for the first order reaction. Okay, unit of K for the first order reaction. So as we have already discussed here, the T1 half is not dependent on the concentration of A because the power is 0 here, and we are also having for any T time reaction. Okay, for the T time, T is equal to 2.303 divided by K log A naught by A. So here when we are writing this equation, it can be written as a K is equals to 2.303 divided by T log A naught by A, and for half lifetime we can write 2.303 divided by T 1/2 log A naught by 2. So finally we got 0.693 divided by T1 half. And now here you can see A naught by A units are mole per liter will be cancelled. So only time will be remaining. For any time, for the first order reaction, here the unit is only and only for the S. Okay, so it means that the concentration is not be written here because here A naught and A is cancel out, and here also A naught and A naught here cancel out, and so we are having the K is equals to 0.693 divided by T1/2. And what is the unit of time? Unit of time you can take as a second, as a minute, as a hours. Okay, so the unit for the K for the first order reaction will be, what will be the unit? So it will be second inverse, or you can also write the minute inverse. Okay, or you can also write the hour inverse. Okay, so I hope you understood how the unit for the first order reaction came second inverse, minute inverse, and hour inverse. Okay, so if you have any doubt, please let me know in the comment section. Here we have discussed about the zero order reactions half lifetime, and the first order reactions half lifetime, and the second order reactions half lifetime, and then after general order reaction. Okay, for nth order reaction, the half lifetime equation we have discussed. So thank you very much everyone for watching this video. Please let me know if any doubt is there in the comment section. And it is very important, what is the half-life period for the first order reaction, which we have discussed in this video. Thank you.